December 29, 1940. Oval Office, the White House, Washington, D.C. 14:37 hours. President Franklin Delano Roosevelt couldn't know that the telegram on his desk, marked Most Secret, stamped with British embassy seals, would transform American industry beyond recognition within 18 months. Behind him, winter light filtered through windows overlooking a nation still at peace. Before him, Winston Churchill's words, transmitted across a submarine-haunted Atlantic. Mr. President, we require aircraft production on a scale that frankly borders on fantasy. Your industrial capacity, while impressive for peacetime commerce, lacks the martial character necessary for sustained military manufacture. Britain alone produced 15,000 aircraft in 1940. We need you to exceed that figure substantially. I confess skepticism that American industry, magnificent though it is for automobiles and refrigerators, can pivot to instruments of war with sufficient speed. Roosevelt read the paragraph 3 times. Each time, one phrase stuck like a barb, borders on fantasy. Churchill had reason for doubt. As of January 1, 1941, the United States possessed exactly 17 aircraft manufacturing facilities capable of military production. Total combined output for 1940, 6,086 aircraft of all types, training planes, commercial transports, and a handful of fighters. The largest single manufacturer, Consolidated Aircraft in San Diego, employed 4,200 workers and produced, at peak capacity, 2 B-24 Liberator bombers per day. Germany, by contrast, was producing 950 aircraft monthly. Japan, 425. Britain, fighting for survival, had mobilized every factory, every machinist, every woman who could rivet aluminum, achieving 1,250 aircraft per month by December 1940. America's contribution to that desperate arithmetic? Negligible. Boeing Aircraft Company, Plant 2, Seattle, Washington. January 15, 1941. 6 o'clock hours. The factory floor was silent in pre-dawn darkness. Plant 2, Boeing's primary production facility for the B-17 Flying Fortress, occupied 1.8 million square feet of industrial space on the outskirts of Seattle. At full capacity, employing 8,400 workers across 3 shifts, the plant could produce 5 B-17s per week, 20 per month, 240 annually. Respectable for peacetime, laughable for war. Plant manager James Murray stood on the observation catwalk, coffee growing cold in his hand, watching the skeleton crew prepare for day shift. Murray was 52, a mechanical engineer who had built automobiles in Detroit during the Great War, then aircraft in the boom years after. He understood production lines, efficiency ratios, the mathematics of manufacture. He also understood the mathematics now facing America were unprecedented. The telegram from Boeing's headquarters in downtown Seattle had arrived at 1700 hours the previous day. War Department requests production capacity assessment. Require immediate calculation of maximum theoretical output under mobilization conditions. Assume unlimited capital, unlimited labor, unlimited raw materials. Report by January 20th. Unlimited. The word haunted Murray through a sleepless night. The B-17E Flying Fortress required 47,000 individual parts. Each airframe needed 160,000 rivets, installed by hand. Electrical systems comprised 180 separate circuits totaling 9 miles of wiring per aircraft. The Wright R-1820 engines, 4 per plane, were manufactured in New Jersey, trucked across the continent, installed in Seattle. Production time from first aluminum sheet to flight-ready bomber, 90 days. Per aircraft. Murray did the mathematics. To match Britain's monthly output of heavy bombers alone would require producing 30 B-17s monthly from Plant 2. That meant reducing production time from 90 days to 30, which meant tripling workforce, tripling floor space, tripling everything. Impossible, Murray had told his assistant the night before. We'd need to build aircraft like Henry Ford builds Model Ts. You can't do that with something this complex. His assistant, a young engineer named Robert Chen who'd graduated MIT in 1938, had looked at Murray with the terrible optimism of youth. "Mr. Murray, I don't think we have a choice." War Department, Army Air Corps Material Division, Wright Field, Dayton, Ohio. February 3, 1941. 10:15 hours. Colonel Oliver P. Eccles reviewed production reports with growing alarm. Eccles, 48, was chief of the Army Air Corps Production Engineering Section, the office responsible for transforming Pentagon requirements into actual aircraft. A West Point graduate, veteran of the Western Front in 1918, he understood military logistics with the clarity that comes from watching men die for lack of supply. The reports before him painted a stark picture. Current aircraft production capacity: 650 aircraft monthly, all types, British request. 2,000 aircraft monthly minimum German production rate. Intelligence estimate 950 monthly Japanese production rate. Naval intelligence estimate 425 monthly required American output to support Britain and build own forces. 3,500 monthly. Gap between requirement and capacity: 2,850 aircraft per month. Every month. 4 years. Eccles lit his fourth cigarette of the morning. The mathematics were cruel and simple. America would have to increase aircraft production by 538% to meet minimum requirements. Not gradually. Immediately. He drafted a memo to Major General Henry Hap Arnold, Chief of the Army Air Corps. General Arnold, current production capacity insufficient by factor of 5.4:1. Achieving required output will necessitate 1. Construction of new factories on unprecedented scale. 2. Training of workforce numbering in hundreds of thousands. 3. Reorganization of entire manufacturing process. 4. Coordination across industries beyond any previous industrial mobilization, including World War I. Respectfully submit this undertaking exceeds any industrial challenge in American history. Time required: minimum 24 months. We may not have 24 months. Eccles. He didn't send it. Instead, he wrote a different memo. General Arnold, we'll find a way. Eccles. The numbers told the story America wasn't ready to hear. In early 1941, the United States Army Air Corps possessed 2,846 aircraft of all types. Most were trainers. Of combat-ready bombers and fighters, the total stood at 1,157. Germany's Luftwaffe, 4,300 combat aircraft. Japan's combined forces, 2,400. More damning, production capacity. Boeing in Seattle, 5 B-17s weekly. Consolidated in San Diego, 2 B-24s daily. Douglas in Santa Monica, 3 A-20 attack bombers daily. North American in Inglewood, 4 trainers daily, 0 fighters. Total American bomber production, January 1941, approximately 60 aircraft monthly. Britain alone needed 300 monthly just to replace combat losses. The first complication appeared February 12, 1941. Boeing received materials allocation for increased B-17 production, aluminum sheet metal sufficient for 12 additional aircraft monthly. Sounds promising until examining the fine print. The aluminum came with a problem. It was earmarked from Reynolds Metals in Louisville, Kentucky. Louisville to Seattle, 2,300 miles by rail. Standard shipping time, 18 to 22 days. Meaning, order aluminum today, receive it 3 weeks later. This created a bottleneck. Can't build airframes without aluminum. Can't stockpile months of supply, no storage space, no capital to tie up in inventory. Production planning becomes nightmare of coordination across continental distances. James Murray, reviewing the supply chain, realized something that kept him awake another night. Every single component of the B-17 came from somewhere else. Wright engines from New Jersey. propellers from Connecticut, instrumentation from Massachusetts, armament from Ohio, tires from Akron, glass from Pennsylvania. Even rivets came from suppliers in Illinois and Michigan. Coordinating all of this for 5 aircraft weekly was manageable. 450 weekly? The logistics became warfare of their own kind. But the real crisis was human, not material. Boeing's 8,400 workers in January 1941 represented nearly the entirety of Seattle's skilled aircraft labor. To triple production meant tripling workforce to 25,000. Where do you find 16,600 trained aircraft workers in a city of 370,000? Answer: you don't. You create them. The first recruitment drive, launched February 20, 1941, targeted Seattle shipyards, timber mills, automotive garages. The pitch: build aircraft for democracy. Good wages. Stable work. Response was enthusiastic but revealed the scale of the challenge. Of the first 800 applicants, exactly 47 had any experience working with aluminum. None had built aircraft. Most had never seen a technical blueprint. Training time to convert a skilled machinist into a competent aircraft riveter, 6 weeks minimum. Training time to convert an unskilled laborer, 12 weeks. Time available before increased production quotas hit, 8 weeks. The mathematics kept getting worse. March 15, 1941. 2,200 hours. Murray's office, Boeing Plant 2. Murray sat with Robert Chen and 3 shift supervisors, reviewing the impossible production schedule Washington was now demanding. They want us at 20B/17 monthly by July 1st. Murray said. That's 4 months. We're currently at 23 for the entire month of February. Can't be done, said Tom Richardson, day shift supervisor. Richardson was 61, had built aircraft since 1919, knew every inch of Plant 2. We don't have the people. Don't have the floor space. Don't have the tooling. Then we get them, Chen said. From where? Richardson shot back. You can't just magic up 15,000 trained workers and 1,000,000 square feet of factory. Silence. Murray looked at the production charts. The mathematics were impossible. But that evening, he made a decision that terrified and excited him in equal measure. We're going to have to reinvent how aircraft are built. The challenge was set. The skepticism was justified. The clock was running. In London, Winston Churchill awaited news from across the Atlantic, hoping America could prove his doubt wrong but prepared for disappointment. In Seattle, James Murray stared at blueprints and wondered if American ingenuity could accomplish what seemed, even to America's closest allies, to border on fantasy. Behind them both, invisible but inexorable, history was accelerating. Pearl Harbor was 9 months away. D-Day, 3 years. The need for aircraft, thousands upon thousands of them, wasn't coming. It had already arrived. April 3, 1941. Boeing Plant 2, Assembly Floor A, 14:30 hours. Robert Chen stood before 140 new hires, first graduating class of Boeing's accelerated training program. 8 weeks prior, these men and women had been loggers, fishermen, store clerks, housewives. Now they wore company coveralls and carried rivet guns, waiting to build bombers. Chen, 26, had become Boeing's unlikely prophet of production revolution. While James Murray managed the factory's operations, Chen was tasked with solving the unsolvable. How do you teach aircraft manufacturing to people who'd never built anything more complex than furniture? His solution was heresy to traditional aircraft production. Break it down. Simplify everything. Make each worker an expert at one task instead of competent at many. Traditional aircraft construction, Chan had explained to skeptical supervisors, treats each plane as a custom craft. Every mechanic knows every system. We build aircraft like artisans build violins, beautiful, precise, slow. "What you're proposing?" Murray had asked. "We build them like Ford builds cars. Assembly line. Specialized stations. Workers repeat the same task until they can do it blind, faster than any generalist could." The supervisors had hated it. "Aircraft aren't cars. Too complex. Too many variables." "Then we'll reduce the variables," Chen had replied. The revolution started with rivets. Boeing engineer Dorothy Peterson, one of 17 women working in technical positions at Plant 2, had analyzed B-17 assembly time. Her report, delivered March 20th, revealed a stunning fact: 32% of production time was spent on riveting alone. Peterson's background was structural engineering, degree from University of Washington, 1937. She joined Boeing designing wing stress calculations, but Murray had assigned her to Chen's production analysis team. Her methodical mind found patterns others missed. "We're doing it backwards," Peterson told Chen and Murray in a late-night meeting. "We rivet from complex to simple, installing structural framework first, then skin panels. This means riveting around completed electrical systems, hydraulics, control cables. Every rivet is a custom challenge." "And your solution?" Murray asked. "Reverse it. Partially assemble subsections off the main line. Pre-rivet wherever possible. Bring completed assemblies to the airframe instead of building everything in place." Chen saw it immediately. "Modular construction." "Exactly. We turn one assembly line into 20 parallel lines feeding one final assembly point." Richardson, the day shift supervisor, shook his head. "You're going to have tolerance problems. Everything has to fit together perfectly. If your subassemblies are off by even 1/16 of an inch." "Then we create standardized jigs," Chen interrupted. "Precise fixtures that hold everything in exact position during assembly. Remove human error from alignment. That'll require building dozens of custom jigs. Time. Money. Less time than training 15,000 people to eyeball tolerances," Chen countered. Murray made the call: build the jigs. "We try Peterson's system on one complete aircraft. If it works, we roll it out plant-wide." April 28, 1941. Boeing Plant 2, Experimental Assembly Station. 6 o'clock hours. The test began. B-17E serial number 41 to 2393 would be the proof of concept. Chen's team had spent 3 weeks building specialized jigs and fixtures for every major subassembly. The airframe was divided into 17 major sections, each with its own specialized workstation. Forward fuselage, cockpit assembly, radio compartment, bomb bay, waist positions, tail section, for wing panels, 4 engine nacelles, landing gear, electrical systems, final assembly. Traditional method: 90 days from first metal to flight-ready bomber. Chen's target: 45 days. Everyone thought he was insane. The first week was disaster. Subassemblies arrived at final assembly station with tolerance errors. Wing panels didn't align with fuselage mounts, off by 3/8 of an inch. Electrical harnesses were 6 inches too short because nobody accounted for routing through new junction boxes. Engine nacelles required custom shimming because jigs hadn't been calibrated properly. Richardson found Chen on the factory floor at 2300 hours, staring at the partially assembled airframe. "It's not working," Richardson said, not unkindly. "We're 3 days behind where we'd be doing it the old way." Chen didn't respond immediately. He walked the length of the aircraft, examining each problem junction. Finally, "Every problem we're seeing is a jig calibration issue or a measurement error in planning. Not a flaw in the concept. Concept doesn't matter if it doesn't work. It will work. We fix the jigs. We adjust the measurements. We try again. We don't have time to try again. Washington wants results." Chen turned to face Richardson. "Tom, What's your read on the new hires? The ones who just finished training. Richardson considered. Eager. Inexperienced. But they follow instructions well. Why? Because those 140 people represent our future workforce. In 6 months, we'll have 20,000 of them. They won't have 20 years of aircraft experience like you. They'll have 8 weeks of training and whatever system we give them. So we can either give them a system that requires judgment, experience, intuition, things they don't have, or we can give them a system so precise, so standardized, that following the process guarantees success. That's what these jigs are. That's what modular assembly is. It has to work because the alternative is admitting we can't train enough people fast enough to win this war. Richardson was quiet for a long moment. Then, how long to fix the jigs? 2 weeks. Maybe 3. You've got 1. Make it work. May 7th, 1941. 1400 hours. Final assembly. B-17E serial number 41 to 2393 rolled out of experimental assembly after 52 days of construction. Not the 45 days Chen wanted, but 38 days faster than traditional methods. More importantly, it flew. Test pilot Eddie Allen took it up for maiden flight May 10th. All systems functioned. Tolerances were within specification. The aircraft performed identically to B-17s built using conventional methods. Murray called a meeting of all senior staff May 11th. We're converting the entire plant to modular assembly. Starting immediately. The transition took 6 weeks. Every production line stopped. Every worker retrained. Dozens of new jigs manufactured and installed. Floor space reorganized. Supply chains reconfigured. June 1941 production. 11 B-17s. Worst monthly output since January. Murray took heat from Seattle headquarters. Washington demanded explanations. Colonel Eccles flew to Seattle personally to investigate the production collapse. "You've cut production in half," Eccles told Murray in his office June 18th. "At the exact moment we need to be ramping up." "Temporarily," Murray replied. "We're rebuilding the foundation. By August, we'll be producing 20 monthly. By December, 40. And if you're wrong, then I'll be looking for a new job." "But I'm not wrong." Eccles studied Murray for a long moment. "I'm going to trust you, Jim. But understand, if this doesn't work, it won't just be your job. It'll be bomber production for the entire European theater." After Eccles left, Chen found Murray staring out his office window at the factory floor below. "No pressure," Chen said. Murray laughed. "Hollow. Robert, I just bet the war on your jigs and my judgment. Let's hope we're right." July 1941. Plant 2 floor, 6 o'clock hours. The new system began showing results. Production time per aircraft, 67 days. Then 61. Then 58. Workers became proficient at specialized tasks faster than anyone predicted. A riveter who spent 8 hours daily installing the same rivet pattern on wing panels became extraordinarily fast. Electricians who routed the same wire harness repeatedly could do it without consulting blueprints. Peterson's modular approach eliminated bottlenecks. Instead of 1 aircraft occupying the entire assembly line, now 5 aircraft were in various stages simultaneously, each at a different workstation, workers moving between them in coordinated rotation. More workers arrived. 11,000 by end of July. 14,600 by end of August. Boeing leased additional warehouse space, converting it to worker training facilities. 3 weeks of classroom instruction, 5 weeks of supervised floor work, then full production. July production, 17 B-17s. August production, 24 B-17s. September production, 31 B-17s. The mathematics were finally moving in the right direction. But Seattle was just one plant. In San Diego, Consolidated Aircraft faced identical challenges with B-24 Liberator production. In Long Beach, Douglas Aircraft struggled with A-20 attack bomber output. In Inglewood, North American Aviation was attempting to design and manufacture an entirely new fighter, the P-51 Mustang, from clean sheet to flying prototype in 120 days. The War Department's solution: standardize everything Boeing had learned. Share the knowledge. Spread the revolution. September 15, 1941, Colonel Eccles organized the first industry-wide production conference in Dayton, Ohio. Representatives from every major aircraft manufacturer attended. Murray and Chen presented Boeing's modular assembly system. The reaction was skeptical. "That might work for the B-17, said a Lockheed executive. "Our P-38 is far more complex. Twin engines, twin booms, tricycle landing gear. Can't simplify that." Chen's response was direct: "Then you'll fail. Complexity is your enemy. Either you find a way to standardize and modularize, or you'll never hit production targets. There's no third option." Silence. Then a voice from the back: "He's right." It was Donald Douglas, founder of Douglas Aircraft. Douglas, 49, had built aircraft since 1920. His company's DC-3 had revolutionized commercial aviation. He understood manufacturing at the deepest level. "Everything Chen is saying applies to every aircraft type," Douglas continued. "The question isn't whether we adopt these methods. It's how fast we can implement them. Because, gentlemen, I've seen the latest intelligence estimates from Britain. The numbers are worse than we've been told." October 5, 1941. Boeing Plant 2, 22:30 hours. Murray received a telegram from Washington. He read it twice, then walked down to the factory floor to find Chen. The night shift was in full operation. The sound of rivet guns echoed through the cavernous space. Sparks from welding torches lit the darkness. 5 B-17s in various stages of assembly occupied the main floor, surrounded by workers who moved with increasing confidence. "Robert," Murray called over the noise. Chen looked up from a wing jig calibration he was supervising. Murray handed him the telegram. Chen read, "Boeing Plant 2, new production target effective January 1, 1942, 60 B-17s monthly. Further increase to 100 monthly by June 1942 under consideration. Immediate assessment of feasibility required." Eccles. Chen looked at Murray. 100 monthly. That's more than 3 per day. Every day. 7 days a week. Plant 2 can't do that alone. "No," Murray agreed. "We'd need to build a second plant. Maybe a third." They stood in silence, watching the night shift build bombers. "You know what's coming," Chen finally said. It wasn't a question. Murray nodded. Everyone sensed it. War wasn't a possibility anymore. It was inevitable. The only question was when. "If they're asking for 100 monthly from Boeing alone," Chen continued, "that means they're planning for thousands industry-wide. Which means they know something we don't. Or they're preparing for something we can't imagine yet." December 7, 1941, was 63 days away. The impossible was about to become mandatory. December 7, 1941. Boeing Plant 2, Seattle, Washington. 14:47 hours, Pacific Time. James Murray was reviewing fourth-quarter production reports when his secretary burst into his office without knocking. "Mr. Murray, turn on the radio. Now." He did. "We repeat, the Japanese have attacked Pearl Harbor. Multiple waves of aircraft struck the naval base this morning. Casualties are reported in the thousands. Battleships sunk. President Roosevelt is expected to address Congress tomorrow. We are at war. Murray sat heavily in his chair. Behind him, through his office window overlooking the factory floor, he could see workers gathering around radio sets, production slowing, then stopping entirely as the news spread. Chen appeared in the doorway minutes later, face pale. "How bad?" Murray asked. "Radio says at least 5 battleships sunk or damaged. Hundreds of aircraft destroyed on the ground. Casualties." Chen's voice trailed off. Murray picked up his phone. "Direct line to Seattle headquarters. Get me Boeing management. Now." Pause. "I don't care if they're in a meeting. Pearl Harbor was just attacked. Everything just changed." He hung up. Looked at Chen. Production target for 1942 was going to be 60 monthly, ramping to 100. That's out the window now. Whatever they're going to ask us to do, it's going to be bigger. "How much bigger can it get?" Chen asked. Murray didn't answer. He was staring at the factory floor, doing mental calculations. The phone rang 40 minutes later. It was Colonel Eccles. "Jim, you're about to receive new production targets. They're aggressive." "How aggressive?" 150 B-17s monthly from all Boeing facilities combined by end of 1942. We're authorizing immediate construction of Plant 3 in Renton. 3.5 million square feet. You'll oversee it. Murray's hand tightened on the phone. "Oliver, Plant 2 took 3 years to build. You're talking about a facility twice its size. You have 14 months. Ground breaks January 15th. That's impossible." "Jim, here's what's possible. Japan has complete air superiority in the Pacific. Germany controls the skies over Europe. Britain is holding on by its fingernails. The only way we win this war is by building aircraft in numbers that make enemy production look like a cottage industry. 150 monthly is not the goal. It's the minimum. Are you telling me American industry can't do this?" Silence. "No," Murray finally said. "I'm not telling you that. We'll do it. I know you will. Plans for Plant 3 arrive tomorrow. War Department has already allocated materials priority. You'll have everything you need. Except time. Then make time. Build faster. Build smarter. Build like everything depends on it. Because, Jim, it does." December 9th, 1941. 8 o'clock hours. Plant 2 main assembly floor. Murray called an all-hands meeting. 14,600 workers packed the factory floor. Many were still processing Pearl Harbor. Some had family in Hawaii. All understood their jobs had just become more than paychecks. Murray climbed onto a work platform so everyone could see him. 2 days ago, we were building bombers for Britain. Today, we're building them to win a war that's going to determine whether democracy survives. That changes everything." He paused, making eye contact with workers across the crowd. "Washington wants 150 B-17s monthly by December 1942. That's 5 per day. From our current 31 monthly, we need to nearly quintuple production in 12 months while simultaneously building the largest aircraft factory in human history." Murmurs rippled through the crowd. "I won't lie to you. What we're being asked to do is unprecedented. Some people will say it's impossible. Churchill himself called American production capacity a fantasy." Murray's voice hardened. "I say we prove him wrong. I say we build so many aircraft that Germany and Japan can't shoot them down fast enough. I say we turn this factory and the one we're about to build into the reason America wins this war." Applause started. Then grew. Then became deafening. When it quieted, Murray continued, "This will require sacrifice. Longer shifts. Weekend work. Faster pace. Less tolerance for error. But here's what I promise you. Every aircraft that leaves this factory will be perfect. Because somewhere over Germany or over the Pacific, American boys are going to trust their lives to what we build here. We will not let them down. The transformation was brutal. Within weeks, Boeing implemented changes that would have taken months before Pearl Harbor. Work shifts changed from 8-hour shifts to 10-hour shifts, then to 12-hour shifts, then to rotating continuous operation. Plant never stopped, workers on 6-day weeks. Training time compressed from 8 weeks to 5 weeks, then to 3 weeks classroom, 2 weeks supervised floor work. New hires went from orientation to building bombers in 35 days. Quality control intensified. More inspectors hired. Every rivet, every wire, every system checked twice. Reject rate actually decreased as workers understood stakes. Floor space, every possible square foot converted to production. Offices moved to temporary structures outside main building. Break rooms reduced. Storage consolidated. By end of December 1941, Plant 2 employed 18,200 workers, producing 38 B-17s monthly. Not enough. Not even close. January 15, 1942. Renton, Washington. 9 o'clock hours. Ground broke on Plant 3. The site was muddy farmland 8 miles south of Seattle. 275 acres. When completed, the facility would cover 3.5 million square feet, making it one of the largest buildings by footprint in the world. Construction timeline: 14 months to operational status. Murray stood at the groundbreaking ceremony alongside Chen, Dorothy Peterson, Tom Richardson, and representatives from the War Department. A photographer captured the moment. 6 people with shovels, breaking dirt, launching the impossible. 14 months, Chen said quietly. Standard construction timeline for a facility this size is 36 months minimum. Then we'll work faster, Murray replied. We'll need to solve problems we haven't even encountered yet. We'll solve them when we encounter them. Richardson, overhearing, shook his head with something between admiration and resignation. You two are either the most optimistic people I've ever met or completely insane. Probably both, Murray admitted. The problems arrived faster than solutions. February 1942, labor shortage. Boeing needed 30,000 additional workers by year-end. Seattle's population couldn't supply them. Solution: recruit nationally. Advertisements placed in newspapers across the country. Build bombers for victory. Guaranteed employment. Housing provided. Response was overwhelming. By March, workers arrived from Oklahoma, Arkansas, Missouri, Texas. Former farmers, former shopkeepers, unemployed men from depression-hit regions. Many brought families. Seattle's population increased by 40,000 between February and June 1942. March 1942, housing crisis. Where do 40,000 people live in a city unprepared for them? Boeing and War Department partnered to build temporary housing complexes. Prefabricated units assembled in weeks. Not pretty, not permanent, but functional. April 1942, material shortages. Aluminum supplies couldn't keep pace. Railway cars carrying aluminum from Reynolds in Louisville were prioritized as military transport, ahead of food, civilian goods, everything. Still wasn't enough. Solution: Boeing engineers redesigned parts to use less aluminum. Every ounce saved on one aircraft meant more aircraft overall. May 1942, power grid strain. Plant 2 operating 24/7 consumed electricity equivalent to a city of 50,000. Adding Plant 3 would double that. Seattle's power grid couldn't handle it. Emergency solution: Boeing funded construction of additional power substation. Cost: $2.3 million. Completed in 89 days. June 1942, assembly bottleneck. despite modular system, final assembly still took too long. Too many aircraft waiting for final integration. Peterson's solution: split final assembly into 2 parallel lines. Doubled throughput. Required reconfiguring entire factory floor. Done in 3 weeks. July 14, 1942. Plant 2, 3:30 hours. Chen found Murray still in his office, reviewing Plant 3 construction schedules. The plant was supposed to be operational by March 1943. Current pace suggested June 1943 completion. "You need to sleep," Chen said. "Sleep when Plant 3 is operational. Jim, you're going to collapse." Murray looked up, and Chen saw exhaustion that bordered on physical damage. The man had aged 5 years in 7 months. "Robert, do you know what happened yesterday?" "What?" Eccles called. "Gave me updated intelligence from Europe. Germany produced 1,200 aircraft in June. All types. Fighters, bombers, reconnaissance. Our entire aircraft industry, Boeing, Douglas, Lockheed, Consolidated, North American, everyone combined, produced 2,100. That's almost double German production. And still not enough. British and American forces are planning operations that will require air superiority on a scale never seen. 1,000 bomber raids. Close air support for amphibious invasions. Strategic bombing campaigns against German industry. Eccles estimates we need 5,000 aircraft monthly by mid-1944. Across all manufacturers. Chen sat down. The numbers were staggering. Boeing's share of that? Murray continued. Minimum 600 B-17s monthly. That means Plant 3 isn't enough. They're already planning Plant 4. And probably Plant 5. "We can't," Chen started. "We can. We have to. Because if we don't, we lose. It's that simple." August 1942. Plant 2, production floor. Something changed in August. A shift in atmosphere. Workers moved faster, not because supervisors pushed them, but because they understood urgency at cellular level. News from the Pacific was bad. News from Europe was worse. Every worker knew someone in uniform. Brothers, sons, husbands, friends. The connection between what they built and who survived became personal. Production accelerated. August 1942. 52 B-17s completed at Plant 2. September 1942. 61 B-17s. October 1942. 73 B-17s. The modular assembly system matured. Workers didn't just follow procedures anymore. They improved them. A riveter found a way to save 30 seconds per panel. Multiplied across hundreds of panels, thousands of aircraft, that 30 seconds became days. An electrician redesigned a wire harness routing that reduced installation time by 2 minutes. Multiply that by every harness, every aircraft, every month. Small improvements, massive impact. November 12, 1942. Plant 2, final assembly. B-17F serial number 42 to 30,177 rolled off the production line. Nothing distinguished it from the others except timing. It was Boeing Plant 2's 1,000th B-17 Flying Fortress. Murray and Chen stood watching it taxi toward the test flight runway. 1,000, Chen said. When this started, people thought 100 was impossible. 1,000 is just a number, Murray replied. The real number is this. In the next 12 months, we need to build another 1,800. Plant 3 comes online March. That'll help. It'll have to do more than help. It'll have to transform what's possible. The B-17 lifted off, climbing into gray November sky. Somewhere over Germany, aircraft like this one were engaging German fighters, dropping bombs on industrial targets, dying in numbers that horrified those who saw casualty reports. And somewhere in Seattle, workers were building replacements as fast as human hands could move. The mathematics of war are cold. Aircraft lost must equal aircraft built. But America was changing that equation. Soon, aircraft built would exceed aircraft lost by margins that made replacement impossible for Germany. Churchill had called it fantasy. By end of 1942, Boeing Plant 2 alone had proven it was reality. But the breaking point hadn't passed yet. The hardest test was still coming.